So this is a video for homework 3, problem 5, and here the problem is that in a trial of 100 patients who received 10 milligram doses of a drug daily, 32 reported headache as a side effect, and we have to use this information to complete parts A through D. So the first thing we need to do is obtain the point estimate for the population proportion and those that reported a headache. So to do this, what we do is we take the number that reported a headache and divide by the total number in the sample. So this would be 32 divided by 100, which gets us the 0.32. Okay, and that's what we basically is the center of our confidence interval. So when we do go to build the confidence interval, that's going to be the number that we kind of build it around. It's going to go in the middle. Okay. Now the next thing we need to do is verify that we do have the requirements that are met to satisfy constructing a confidence interval. And this is that n times p hat times 1 minus p hat is greater than or equal to 10. So to do that, I'm just going to go and get my calculator here. So first of all, my p hat right here, this is my population proportion, well, it's the point estimate for the population proportion, is 0.32. So to do this, I'm going to take n, which is 100, so I'll do 100 times 0.32, so times 0.32, and then times 1 minus p hat. So in this calculator, or if you have any small scientific, just use your parentheses here, and we'll do 1 minus 0.32. Okay, it's also what we call the complement percent of 32%, so 100 minus that, and press equals. So that is going to be greater than or equal to 10, so that is going to be satisfied. Okay, so we do have, yes, the requirements for constructing a confidence interval are satisfied. Okay, the other part, let me just show you here and view an example. The other part of satisfying your confidence interval is that n is no more than 5% of the population size. So when you think here of, you're dealing with a number of patients, right? So because you have your independent samples, we're always going to assume that whatever value they're giving us is less than 5% of the population. So once we know that, those two conditions means that your requirements are satisfied. So we're good here. As long as this was sampled, again, random sampling causes us to do that. Now to construct the 95% confidence interval, again, what we would have to do is get our margin of error and then add that to 0.32 and subtract that from 0.32. But you can actually do this in StatCrunch in a really easy way. So if you go to question help and then click StatCrunch, what I'll do here is I'll go to stat, we'll go to proportion stats, pick one sample with the summary. We don't have all the data, but we do have the summary of the data. So we have the number of successes. Now I know having a headache is not a success, right? But it's the part that was experiencing that particular side effect. So 32 people experienced the headache. 100 is the number of observations, or the total sample size. We're running a confidence interval, and we do want it to be 95%, so we'll leave this at 0.95. I believe it was 0.95. Yes, okay. And then we click compute. And you can see here that it actually computes the standard error for you. So what it does to get the lower limit and the upper limit is it takes that 0.32, the sample proportion, p hat, it adds the standard error, and it subtracts the standard error. When it adds the standard error, you get your upper limit. When you subtract your standard error, you get your lower limit. And I believe we're getting the correct values here. Yep, they're rounding to the hundredths place, thousandths place, 3 decimal places. And it looks like we got the same values, 0.229 and 0.411. Now the last thing here is how to interpret your confidence interval. There's kind of a formula to the sentence that goes with doing your confidence intervals, and this is the basic formula here. So we are 95% confident that the interval contains the true value of p. So if I were going to put this in the context of the problem, I would say we are 95% confident that the true population proportion of the number of people who will report a headache is blank, between this and this. Okay, but this is just the very general sort of formula here. So let me know if you have any more questions.